visible? Yeah, you are audible. हाँ, आपकी आवाज गुड आफ्टरनून. ओके, सो मैं फुल स्क्रीन करूंगा, फिर शायद मुझे आप लोग दिखोगे नहीं, बट स्टिल आई विल टेक assume that people are watching me. And is my screen visible properly? पहले ये कंफर्म कर दो. ओके, फाइन. अभी भी दिख रही है? ओके, फाइन. सो first of all, I'll acknowledge my team at NPL, Dr. Rajesh, Dr. Sumanna, myself, Arun Khan Singh, Sudesh, Vinod Kanwar, M.K. Pandey, Vikas Garg, and Vishesh. And also, I would like to thank our director and Dr. Rajesh for supporting. Also, I would like to thank the organizers, Dr. Atul Kumar, uh, head in charge, PG Department Chemistry, conveners Dr. Sumit Kumar, Partha Pratim Das, Supriya Kumari, and Shukra Solanki for giving me this opportunity. It is indeed a pleasure to connect with you people. बोध गया के बारे में हमने बहुत सुना था, पर कभी frankly speaking कुछ भी नहीं देखा था. So at least I'm happy that Shukla is there and चलो ठीक है, अभी तो ऑनलाइन दे रहे हैं, but definitely someday I would like to visit the institute place because ancient India, the knowledge originates from that. It's well known, and I hope in future also you become the center of knowledge in India. That's my wish. So, without wasting a time, let's start with the topic. So, the motivation of work is it's not from today, but since long time. But during time of COVID, this motivation become really cemented that we should have affordable, rapid, and on-site, which we call point of care diseases. Um, because during COVID, we have seen that people, the entire hospital was shrinked into a small homes, and everybody had those instruments. Earlier, people were scared what is BP. In fact, I know even for myself, भले ही मुझे BP ना हो, but if somebody starts to measure my BP, I used to get higher BP just because it is being measured. Okay. So, but COVID was a time when people started keeping all these instruments at a home. efficacy. So if you are aiming for devices for home, do this such devices really qualify? No, they don't qualify. So what is an alternate? Alternatives, people are working on paper microfluidics, something which we all know that dip test. This is also, one can say, is an example of a kind of paper microfluidic where you put a drop of being a blood, urine, or anything, and you get a quick test. Even swab samples you can put in this kind of thing. So paper microfluidics is really coming up and replacing the conventional microfluidics. And so what really goes into paper microfluidics is a paper, as name suggests. But paper is just a symbol. It need not be paper. It can be a two-dimensional substrate which is flexible. It can be of cellulose or it can be of nylon. Anything which gives you option of functionalization, holding the substrate and performing the test. And mostly these tests are calorimetric, meaning you will sense some change in color. Okay. So, like I mentioned, on your left, you have a conventional lithography-based microfluidic channels where we have used an ITO and then we had PDMS block on those 3 lines. If you see, they were made using, ICU8 using photolithography, and then again photolithography was used. So it was some 7 to 8 step process. Okay, and it was very critical. On your right, you see something which both of the work is from our lab. On your right, what you see is just on a paper. We used a 2D plotter. 2D plotter, we had our own 2D plotter, and we had just made circles which confines the flow of liquid. This is like hydrophobic boundaries. So liquid will remain inside. This hydrophobic boundaries you can make using wax or even with PDMS or anything which can stop the water flow. So a quick comparison, the conventional PDMS needs a driving pump. You have to have a pump because those channels are very fine. So you need to push that liquid inside it. But the paper microfluidic, the pores behind, like in your trees, the water inside trees again is an example of capillary action. Cellulose is known for it, and all pores it has, so it can suck the liquid to certain level. And but liquid can go from really ground to 22 feet high tree. So why not in a paper? That's something very easy. You don't need a active pump for that matter. Fabrication, if you talk about fabrication, you don't need clean room and photolithography. You can do, even the college students can, or even school students who are really good with the open hardwares and all, they can use 2D plotter. And even with the hand, you can write those channels. It may be very cumbersome, but something if you have a pen in your hand, which has a special ink, like hydrophobic ink, can give you paper-based microfluidic channel. Reagent, so you need sometimes cold chain, but here we apply the reagents. So, and the functionalization is a key. So dry agents can be used. Disposable, I would say both are more or less same, but because on your left you have a liquid, so little precaution has to be maintained. On right, since it is already in a dried form, yes, both of them stands equally. The cost is very high for conventional microfluidics, but paper microfluidics, yes, it's very cheaper. But these days, the cost of paper itself has increased. So post-COVID, I would say the cost of even paper microfluidics has gone up, but still it is comparative to conventional microfluidics. It's still on a cheaper side. And flow control, yes, on this, the conventional PDMS is always winner. This is like you are at the mercy of a type of paper and the fibers and the pores inside it. So liquid goes on its own. You cannot dictate the liquid where it has to go. For dictation, yes, you have those boundaries, but still it's little cumbersome and messy. So if you ignore this last parameter, flow control, on all the other aspects, the paper-based micro pads gets an edge over conventional lithography. Uh, so the core principle of this is that the if you place a drop of water, it will try to spread in all the directions. But if you can create a wall, uh, or like just like a road or footpath, where you do not allow the liquid to go in all the directions. So just like in hydrophobic walls, so liquid will be forced to um, flow or will be directed in certain which we assume that will be a channel. Speed is not really at your hand. The liquid is getting its own speed depending on the porosity of the paper. So these walls, you need something which is hydrophobic, and we thought of PDMS, not just we actually. This work first was done by sites and they use PDMS, so we are also using PDMS. But PDMS is very thick. So you need to dilute it, because if you want to write it for the first time, so you should have a carrier organic substance, something like hexane or toluene, which reduce this viscosity and this. So it has to be mixed in certain ratio. Again, one has to figure it out what ratio is appropriate for them. So this is subject of study, and then you create hydrophobic channels. So for that, finally you need a drawing in which pattern you want to draw, and you again need a desktop plotter. Now, since we were already in a cost cutting and this work started during the time of COVID, we did not have a time to go and purchase an expensive equipment, so we developed our own 2D printer. This is not something which is very novel. People can develop. In fact, college students or engineering students often develop their own printers. So what we did was we had 3D printer at our lab, which was again Prusa RapRap 3D printer, which we had assembled. So we just took out its Z-axis, Z-axis, and instead of 3D printer, we were using it for a 2D printer. Okay. So what are the advantages when you have such a the conventional, the very first project which was published by Whitesides, they were curing it at the 70 degrees and duration was 1 hour, which we thought that for such a small quantity of liquid, 1 hour is too much, though the temperature was appropriate, but still 70 degrees is still on the higher side for many biological reagents. So can we work on this? So that was an idea. And so these were the initial ideas that system. Now we freezed on, let's work on a paper microfluidics. It doesn't require those expensive prototypes, so it can be done in quick. Like you can print like a conventional paper. You can get 1,000 prints in your printer. So similarly, you can print as many as patterns, and the technology was fast, and it can, depending on, also it uses chemicals which was stable because it has to be on surface, mostly based on the functionalization of materials, not the liquid materials. So paper microfluidics really has an edge over the conventional microfluidics, and if anybody is thinking to start work on microfluidics, so takeaway, talked about the comparison between conventional microfluidics and the paper microfluidics. So we know that being in India, where still we are setting up many things, and the cost is an issue, reachability is an issue. It's not that we have connected roads and everything can be created everywhere, and people wants their own, or hospitals, everybody wants their own system. So these are the advantages what we had over, and for long term, if you really look for the Atmanirbhar Bharat, yes, we should indeed have our own point of care system, which is microfluidic based systems. Okay. So yeah, so what we have developed was I think some problem with the latex. So this was what you can see on your uh, wrap printer, 3D printer, but we disabled its Z-axis. You can see there is which we filled PDMS hexane solution, and through the pipe we were and we also removed the extruder of the conventional, and we were just having the syringe, the final output, and we were using the hot plate, hot bed, which was embedded with the conventional 3D printer. It can go up to 110 degrees Celsius, but we were using at moderate temperature. Right when we are writing, we were actually curing the ink as well. So this is our schematic. And, we mixed PDMS to hexane, the ratio of 3:1, and idea was to have little uh, the ratio of hexane is higher in this because we wanted to reduce viscosity to the large scale, because otherwise it will not flow in that tubing, which later on we had changed, but this is an initial work. So to ensure the proper viscosity, uh, this is an optimized value. It becomes too dilute. So you can see that it is not really stable. If you see on your right, we have this three measures, which shows how with the time this patterns, even after curing, uh, it spreads. So if you see the very first image where we have made a star, uh, so it was just after 1 hour, and you already see that the lines, all the lines of stars are not equal, meaning just because we took a little time in writing them, by the time we reached to the other end, the ink was already started to spread, even when we tried curing it. So you can see that edges of the same one star is not uniform. And if you leave it just like that and observe, after 3 hours, there is a spread, because the curing is not uniform. Paper has its own thickness, and there are um, small pores which will never dry up. Uh, so the ink was spreading, and after 20 days, that is what we assume is a maximum. And we have seen that star had become really bulgy star. So the ink was spreading with the time. So how do we get rid of this problem? This problem essentially came because had it been pure PDMS, you would have not got this problem. This problem occurred because you are diluting it with an organic agent. But then there is a downfall. If you remove the hexane or toluene from a system, it will not behave like an ink. So this is little study where we have done a comparison of different paper. So we thought that let's change the paper itself, because there are paper which, for example, Wattman is cellulose based system and Biodine C is nylon based system. So we thought that is it, can we solve this problem by changing the paper at first place? So yes, indeed. If you see red and black line, in which the black one is the one which is being cured, and the red one is one which is not been cured. So there is a substantial difference. The ink was not spreading much uh, if it is cured, but it spreads by 0.05. And this In another study, we have kept the speed variable and flow constant. But from this, we have found that you have to dispense 4 microliters per minute at this particular speed. 4 and 5 is what we observed. 5 is something which is giving a good result for all three. But 4 was giving good result for immunization. So for immunization, particularly we use 4 microliters. While for biodiversity, we have only 5 was and then we tested how good are these channels to in terms of restricting the liquid. So as you can see that after making 6 patterns, we have just placed the color drop. There is just a color drop and it is indeed flowing only in that channel. So this further confirmed that is what we made was this was just a study, not with any intention, but to see that whether the colors will appear as it is on a substitute or not. So we had two color solutions of different medicines like aspirin, ciprofloxacin, paracetamol, and we at one point thought that it can be made in like such large structures. So, and all of them give different colors just by addition of right. So we placed this different materials on the two different sides and when we placed particular solution was indeed giving different colors. And those colors were interestingly visible with the naked eye. So that was good. So we compared the color which we got in the textbook and added to UV spectroscopy and also with the image. And indeed it was comparative, but on the paper you definitely always get lesser color feeling. So then we thought that can we take it to the next? Can we work on something? So what we did was reading. Now reading is like kind of gold standard. If you really want to see whether your kidneys are looking in the and it is also it is the gold standard for finding colors and the unique. So we started with creatinine and the normal test of creatinine is using the jet-based action, which usually requires the glucose spectrometer and large sample volumes. We got that just as a model system can be used. And so with this idea, we started. Now we had done another addition to the previous work. That addition was that instead of using the form, we thought can we make it further simpler in process of making. And so we replaced with the rotary camera. People who are there's all these people, craftsmen, they use this rotary fan just like a real fan, but it is much more precise in terms of to get actually they can do. And the flow of so we eliminated the signal count in this case and we use the rotary fan. And this is just in the result. But for this, again, we need proper configuration between the system. And we use again because we were using this drawing technical drawing fan. We use the technical drawing fan for different thickness from 0.1 to 0.9. And then we figured out that 0.5 mm was one which is very common in the market and it is giving the best result. Though we tried with other thickness, but then either they were clogging or they were releasing a lot of liquid. They were getting too thick. So 0.5 mm is what we optimized it. And initially we started writing with the conventional ink since it was working. So we shifted back to our own ink, and we started with same Jeffreys reaction and see whether what colors we can see. Now again we had to optimize the flow rate because this we really did not had any control over the flow rate of ink in this case because it was all from gravity. In fact, the contact with the substrate was very critical in this. How much pressure the pen was making on the paper was critical for writing, and it was very difficult to plotter. So one has to also keep in mind that how much pressure the pen is exerting on a pressure. Sometimes initially it used to tear off the paper, and sometimes it was never making us contact with the paper at first place. Anyway, after all this optimization, we had we have moved to the next level. I will come to the so these are the micro fabrication we have done using those plotter with a pen with the and for this, like I said, we had used this DIY wrap 3D printer and used the technical pens and the ratio was 1:1, and the speed of printer was around 200 millimeter per minute for complete absorption of hydrophobic solution on a paper substrate. And the designs were made into Inkscape, which is again an open source problem. So I will. So I'm a big advocate of open source projects. So no way we have used also an open hardware. Inkscape is also open source system, and it uses the G code. And again, for interfacing, we use open source software, and we wrote such patterns. The idea was to do a comparison of why we had this kind of pattern that I'll come to later. So we again analyze those barriers with the contact angle measurement system, and we also studied the times that how much contact angle is changing with the time, because as they dry, they lose, they spreads, and their contact angle actually decreases. The hydrophobicity, which it's supposed to have, changes with the time as it dries up because of the dilution or spreading of the PDMS channel. So these are the images, as you can see, that with the time, as the barriers are spreading, the contact angle is also changing. Again, these are the AFM studies, shows that where we have used on immunodyne paper with and without PDMS. So what are the changes in roughness? And indeed, in this case also, the immunodyne ABC is the superior paper to work on. These are the typical concentration of creatinine human system should have. Here, here how to prepare a Jeffreys reagent, and we have used an artificial urine system to do all these experiments. You can always find so in our lab we make artificial blood, artificial urine, artificial tear. Being a metrology lab, this is our bread and butter. So the artificial urine was created, and Jeffreys reagent was done, and so now on your left, those circles which we have made, actually at the center we have created a reference, and we have changed the concentration around that different circles, and one of them would be the real sample, and rest would be the for a comparison. And so this is like we have made Android system small app using this, on which at the center actually you have the the samples from a patient, and outside you will have a known colors of different concentration, and we'll compare uh, to which color it will be closest. For example, in this case, it will be closest to 0.5 mg. Uh, so that is how we give a concentration. So we cannot give very defined concentrations, but we can give something which we can read through eyes and compare. So we have a 6 reference concentrations to give, and if you really see through software, all these 6 have a different intensity of red and orange, which we have done using program ImageJ software, and so this, and they were giving a quite intense color to the full saturation, as you can see from the linear plot, and they're also in the linear range. So it goes your system, though there is one outliner, but then the repeated measurements, those things were optimized. So we have made a colorimetric sensor, a crude sensor for creatinine for home use, and these are like some selectivity studies uh, for for other interference which we can have in our urine along with the creatinine. For example, albumin, glucose, urea. So all those things were studied, and we found that indeed this the mechanism through which JFase, I mean, it is not we have done something, but JFase is very selective to that. But indeed, whether this selectivity is transferred onto the paper-like system, is our ink or anything on a paper, is it really contributing to that? So indeed, no, it is not contributing. So JFase reaction was successfully occurring on a 2D substrate, that is our nylon paper as well. So this is just to clarify that. And so as you can see that we have given a report of interference from the RGB values, and RGB values is nothing but splitting those colors component. As you can see that they were more yellow, so least blue component, and so this is again mathematically computing what we have really seen, because we can be subjectively wrong with what it is really close to. So one should actually do the RGB analysis, and these days Python program do help for you. You can find a color distance and get the closest color out of it. We have also done the UV spectroscopy of same, and in the solution phase, indeed, it is much more linear, and we can find the detection limit and standard deviation, as you can see. In a test tube, yes, JFase reagent is working fantastic, and it is being equally transferred to the same level of success on a 2D paper. So this is what I was trying to tell, that the 2D paper substrates are no less than the conventional microfluidic systems, and it can be used for disease detection, and as it is easier to fabricate and involves something even a college student or a 12th class student or somebody who's hobbyist can also create such patents at home using those open hardware system and create their own microfluidic devices, or you can think of something else as well. You need not be limited by the expensive equipments or lithography steps. And we have done a model system like creatinine for this kind of work. One can also make agricultural sensors, which we have done from our papers. You can see it is not included in this presentation. Yeah, but that is whole objective of using the paper method. Thank you. So I didn't know my camera was off. Camera was off all the time. Okay. Okay, good. Please. So we could not control the ink flow in that. In fact, ink flow was as per it. We were only moving or controlling our writing speed. So we figured out that at what speed it was releasing the ink. Only the writing speed was controlled, not the flow of ink from the pen. Yes, but what one thing which was dictating a flow, like let's say you have an ink pen, till you will not make a contact of ink pen with the paper, the ink will not come out. Okay, moment you lift your ink pen from a paper, the ink will not come. It's not that ink will start writing. Moment you make a contact of your ink pen and move the ink pen, the ink automatically comes because it forms a meniscus and continuation. Okay. So the same thing was happening in this case also, that the flow was controlled just by gravity, but it only happened moment you make a contact with the paper. Moment you lift off that pen, the ink will not be moving, just like your ink pen. My screen is still there. Stop sharing. Okay. Uh, okay. Okay, welcome. Yes, you are very much audible and
On the behalf of on the behalf of everyone present here, I would like to express our sincere gratitude to you, sir, for sharing your valuable knowledge on this topic. Your lecture was beautifully highlight how innovative approach can make advanced analytical tool more accessible, affordable, and practical for real-world applications. The way you connected
I think there
cutting-edge
is some
research
connection
with
issue.
everyday challenge is healthcare and agriculture was truly engaging. Your discussion on hybrid fabrication technique and smartphone assisted diagnostics has given a fresh perspective on how science can directly impact society, especially in resource-limited settings. It was not only informative but also highly motivating. Highly- So I would like to express my thanks to you and thank you all.
Thank you.
Hello. Yeah. Yes. Okay. विजिबल होगा पीपीटी. Okay. Hello. Yes, yes, yes. You are audible. Yes, my voice is audible. Thank you, Dr. Samit, for nice introduction. I am also very thankful to, as I already said, Dr. Sumit, to invite me to give a talk in such a nice conference. Today, I am giving my talk on the efficient synthesis of the type peroxide using a robust and economical method. As we know that there is a large number of peroxide in which the ABO3 type has a more efficient application in the area of electronics, biosensor, sensing, and biological science also. So here we have synthesized the most of the ABO3 peroxide oxide for the capacitor and energy storage application. So as we know that in the case of modernization, as we know that we are using the cell phones, digital camera, notebook, computer, and etc. For that purpose, we need a energy storage devices. For nowadays, there is a large number of energy storage devices we are using, like lithium-ion batteries and super capacitor and metal air batteries. There are lots of number of research are going on. In out of them, one of the most important energy storage devices is the capacitor. As we know that the first time the computer has been made up by the Charles Babbage, it occupies a large room number of size. It means it has a energy and power to supply for that. It is a large component is there. But nowadays we are using the palm top cell phones. They are very small in size. How it has happened? It has happened due to because each and device which will be smart, and that will be happen the nanoscience and nanotechnology. As we know that the nanoscience and nanotechnology convert into the particle size within the range 1 to meter. For such cellophanes, digital camera, notebook, and although in fans and also in the missile system and drone system, they are also using the capacitor. Capacitor is the important part of these electronic devices. So as we know that in the term of capacitor, so capacitor is a device which used to energy storage in a static power supply. For that purpose, we need a material which has a high dielectric constant and low loss. It means the dielectric constant of that material must be high and the energy loss. Sometimes we are using the capacitor and it can be displace the energy in the form of heat. So for that purpose, we need a low dielectric loss. So we have researches on the several type of material. Like, so one of the material we have discovered in the is that calcium copper titanium oxide. So that material is much far better than the present material. As for that purpose, the present material have the bulk material. So we are the chemists, so we have to use the different type of synthesis method for the synthesis of these material. So we are using the nanochemistry. So in the case of nanochemistry, we have used the metal oxide and metal ions in of the nanoscience is that it has the high dielectric constant. We can also make a electronic component which have the small in size, and also we have to modify the for that purpose. There is a large number of methods we have to use to preparation of the particle, as we have well known that physical method, chemical method, and biological method. As the physical method, they are the mechanical method and sputtering, electric arc deposition, and ion beam technique, molecular beam FATXC. They are the large number of physical method, but in the case of the physical method, they have the tedious work and multi-step reaction. Also, we have used to synthesize the nano-size range of particle by using the chemical method. There also there is several methods like co-precipitation method, Sol-Gel method, microemulsion, hydrothermal synthesis, sonochemical synthesis, microwave synthesis. These are the large number of chemicals method we are using nowadays to prepare the synthesis of the nanomaterial. Out of them, one of the most Sol-Gel method and combustion synthesis method is the most appropriate method to synthesize the metal in the nano-size material in the lab scale. But on the large scale, it is very difficult to synthesize the nano-size material. We have also used the biological method, like we have used to plant extract and use as a reagent in the case of the synthesis of the material. We have also used as the enzyme. We have also used the agriculture waste like baggage and other type of waste which for the synthesis of the nanomaterial. But in all the cases, we have seen that these methods are the multi-step methods, and they have also needed lots of tedious work in the lab, and it is used for the mass production of it is too difficult of these methods. So we are discussing about the capacitor material or dielectric material. Nowadays, we are using the capacitor having the barium titanate and lead magnesium niobate oxide as a dielectric material. In the case of the barium titanate, the problem in those two materials is that these materials are already commercialized, but the problem is that first one is not eco-friendly because the lead containing material is not good for the environment as well as the human being. One of the material is the barium titanate. In the case of barium titanate, we are using nowadays as a commercialized material, but the main problem is that in that material it has a low dielectric constant. The dielectric constant is realized between 2000 to 3000 at a room temperature. But also the dielectric loss also is high. And one of the more disadvantages of that material, it has so the large number of phase transition. It means it changes the structure. It means it is a highly unstable with the temperature not suitable, because if we want to these material to use in a missile system and aerospace system, it is not a better material. So for this purpose, we have to use or provide discover or new material which have the high dielectric constant with the low dielectric loss. For this, in the search of that material, we have to require a material which may be a ideal capacitor. For that purpose, we need to, if we need to storage a high energy, we have need to a very high dielectric constant. Presently, the barium titanate has 2 to 3,000 material. So if we search a material which has a very high dielectric constant more than 10,000, it will be much better for the electronic devices. If also the low dissipation energy, it means the low dielectric loss, it will be greater material, because if the energy loss is low, it means it will be a better material, better dielectric material for the capacitor. The third one is the high thermal instability. As we know that the most of the devices are heat up and at a high temperature or more than 100 degree centigrade, the working of this material is not possible. So if a material which has the highly thermal stable must be defined in the aerospace system as a missile system and the other electronic system is required. So such type of material will be a good material if the material is thermally stable to up to 500 degrees. The fourth one is no variation in dielectric constant with the temperature. The main problem is that the first one is that the barium titanate, the phase transition is possible with the temperature. It means it changes the phase structure. So it is not a good material. If we have to search such type of material which has no variation with the temperature as a dielectric constant, it will be much better than. Also that the one of the most important thing is the frequency, and we know that the every material work in a certain frequency range. So dielectric material with the independent on the frequency, it will be good material for the. These are the requirement, the ideal capacitor material for the advanced electronic device. As we know that we are using the barium titanate, but for the we need a high capacitor MLC multi-layer capacitor material and a high energy storage device, because now we are using the lithium ion battery and but the capacitor also providing such type of an alternative port to energy storage devices. Nowadays we are using the energy storage condenser and other small electron pi as a capacitor material, because the capacitor provides the static power supply to any electronic instrument. So there is no alternative of the capacitor. For we have to search a oxide family, and a oxide family is a ACU3Ti4O12. This family has a formula where we can replace by the A by calcium copper titanate. Whenever we replace by this material calcium copper titanate oxide, we know that it is also known as a CCTO, and this CCTO also be the AVO3 type peroxide. So this material is a very interesting material. As in further slides we are shown how it is a interesting material in the nowadays. So what are the factors on which the we have to focus on this issue? One of the last slide we have seen that the if for the ideal capacitor material, if having the dielectric constant more than 10,000, it will be much better material. So for that material CCTU, it has a more than 10,000 dielectric constant. It means it will be a better capacitor material for the futuristic device. Also, it has been also seen that in that material, it is independent of frequency up to 10 megahertz. So one more thing is the thermally stable, and also along with it is independent of the frequency, as well as it is also the thermally stable. It means there is no phase transition between the 100 to 600 Kelvin. So this material is much better than much far better than the commercial material barium titanate as we are now using. So this is the structure of the calcium copper titanate. It is a BCC structure, so it is not to be discussed more in that one. So the high dielectric constant material is present in a CCTO. In CCTO, high dielectric constant is present, but there is a large number of factors which are responsible for the high dielectric constant in that material. There are the two factors: intrinsic factor and second one is the extrinsic factor. Intrinsic factor means there is a local dipole moment associated with the Pi ions. Also, along with the sometimes it's a polar material. And the other one is the extincting material. Later on, I will discuss the polycrystalline, because one of the theory in the case of the most probable theory for the high dielectric constant of this CCTO is the polycrystalline, semi-conducting grains and insulating grain boundary. I will discuss later on the next slide. And single crystal domain and its domain boundary. They are the few reasons how this material possesses the high dielectric constant. So high dielectric material, there is a large number of reasons for that one. See, one of the most reason is the IBLC intercapacitance between the semi-conducting and insulating grain band, because in the case of the CCTO they have the different type of grains. Some is large grains, some is small grains, and it may be interface between that. The in grain boundary, it is a insulating boundary, and it can causes the high dielectric constant of that material. But we need a high dielectric constant for that purpose. So that provide the good material for that one. So as we know that the doping and doping is external metal ions and other things we have to use to make a material to make a high dielectric constant or low gas. One thing is in here is clear that we for a commercial capacitor material or dielectric for the capacitor material we need a high dielectric constant material, as well we need to low dielectric loss. As we know that the CCTO may be commercialized, but there is one drawback of in the case of the CCTO has a high dielectric loss. For that purpose, we have to use a different type of dielectric, different type of the metal. We have to dope inside it, and we have to replace the cationic anionic solution. Also, along with the we have to use this method to synthesize this material, because the synthesis and processing parameter also affect the dielectric constant for that material as well as the dielectric loss. In the case of the different processing parameter, as we know that when we synthesize the material, it has a different type of processing, like this as a sintering temperature, calcinating temperature. Along with also we have to use a different type of atmosphere. So we can change the properties of these material by the doping. Secondly, we have to use the different synthetic method. Along with we have to use different various processing parameter for that material. In the case of synthetic material, dye method, bit method, and semi method I reported already. So there is a when we have substituted in the CCTO, we have clearly seen that there is a large number of organic substances. If we have to substitute titanium by iron, the dielectric constant may be more than 1 lakh. And also cobalt, tin, and lead, manganese. So we have seen that the dielectric constant may be influenced by the substitution of that material, and we have also substituted by the calcium by lanthanum, and we can see that in these reported literature that this substitution can affect the dielectric constant on that material. And along with this processing parameter, whenever we have to fluctuate the sintering time, and then the dielectric constant also will change. In the case of we have to long duration of time sintering of the material, it can be the dielectric constant may be high up to 18,000. It means the sintering parameter also affect on the dielectric property of these material. So main objective of that material is that our research is that first is we have synthesized the material by different method like dry method, bit method, and the semi-bit method. In the case of the material, in the case of these synthesis material, in the case of these synthesis material, the different type of the solid state reaction need a large number of metal oxide are synthesized and it will be synthesized at a very high temperature, like more than 1000 degree or more than 1200 degree, and it also needs a long duration of time for the synthesis. Second thing, the TiO2 is the main component. Titanium ion is the main component of that material. It means it needs a titanium reagent in the synthesis of this material. For that purpose, we have using the solid TiO2. But in the case of if we want to use the co-precipitation method and bed chemistry method, such type of method needs a titanium oxychloride and titanium isotoxide, which is a very highly in cost. So that is the problem then. Other one is the semi-wet method. For in the case of semi-wetted, whenever we use the titanium oxide as a solid state form, it also needed sintering as well as the calcination of the, because whenever we use the glycine, urea and other type of hello. Now I am audible. Again. Now it is okay. My screen is visible. Okay. So we have discussed about that there is a last. So we have used here a method which is a non-aqueous method. So we have to use this also known as semi-wet route. For this purpose, we have to use the TiO2 as a solid state containant, and also we have used the non-aqueous 2-methoxyethanol for this synthesis. So these are the comparison of the different synthetic routes. We have we have discussed about the automatic flame synthesis and chemical route and conventional solid state route. In the case of automatic synthesis route, we have clearly seen that whenever we synthesize this CO2 material in the lab, it will take mostly to 30 to 50 minutes to prepare the precursor powder. In the case of we have to use the chemical route, we need a large multi-step like preparation of metal ions, citric acid, use the glycine method, precalcination and other. It will take more than 30 to 42 hours. But in the case of the conventional solid state, it can take more than 48 hours. And use this method, automatic flame synthesis method or non-aqueous synthesis method, it will take only the 30 to 50 minutes to prepare the precursor powder for this synthesis. So that means it is a better material to prepare the by using the automatic flame system. One of the most advantage of this material is that we have to use this material to mass production level. Mass production means it can be used for the industrial purpose, for the use of uh, different type of capacitor material. So we have used to different type of characterization technique to synthesize this metal, and this metal will be different type of physiochemical characterization used for like XRD same, EDX same, and SAD pattern. And we have also studied the dielectric and electrical property of that. So this is the systematic diagram for the how we will synthesize the CCTO material in the laboratory. First of all, we have to use the different type of metal ions, and then sonicate in the 10 to 15 minutes in the solution of the 2-methoxyethanol, and for the magnetic sting time to grade. So after to 35 minutes, it can produce a huge amount of gas and large amount of combustion of the material, and we can get a precursor powder. And as we can see that the precursor powder will be formed 50 to 65 minutes. It means whenever we study these electroceramic method in this ceramic electronic industry, it will take a more than 2 and 3 days. But in the case of this method, it will provide the very small duration, as well as we have used to saving the energy and time. We have both we are saving, and it is also provided SDG, sustainability development goals, for the low use of energy and as well as the duration. So this is the XRD crystal structure of that one. It is a CCTO phase. We have given a cubic unit cell structure, and we have compared with and it is a single phase material. It means that we have used that material by synthesized by the non-oxidation synthesis. The XRD crystal structure does not end. It means it to provide the simple cubic crystal structure by using the XRD, and it is a great method for the synthesize. Here we have used to determine the morphology and also conventional that the material containing the conformity that it is a pure or not. For that purpose, we have used the scanning electron microscopy. So for that purpose, we have to use the pellet type of pellet to provide the morphology. And in the case of pellet, we have seen that there are two type of grains inside the morphology. Some are very large in size and some is very small in size. As we have discussed that already, that the morphology of the CC2 is a bimodal in nature. Bimodal in nature means it is a two types of grain, and big grains and small grains, and there is a grain boundary is here. So in the case of the grains and grain boundary, we have discussed the IBLC. IBLC means the internal barrier layer capacitor. In the case of the internal barrier capacitor, the material showing the high electric constant at the grain boundary, which will be the insulating in nature. As well as we have seen that whenever we use to EDX, in the case of EDX, we have seen that the material containing the calcium, copper, titanium, oxygen, and it will well deserve that the material which it will be synthesized by the aqueous non-aqueous synthesis, it will be pure material, and it can be given by the EDX analysis. So we have seen that the morphology containing the bimetal in nature, as well as the material synthesized by using this way, so the confirm the purity of this ceramic, because the calcium, copper, titanium, and oxygen present in the stoichiometric ratio, as we have discussed. We have also used the energy diffusion X-ray mapping and seeing that all the atomic elements like calcium, copper, titanium, and oxygen present in the uniform. So this method provides that the formation of the uniform composition of that material, and clearly shown by the EDS mapping. Here we have also shown the X-ray photoelectron spectroscopy XPS. In the case of XPS, we have seen that the calcium, copper, titanium, oxygen are present. In the case of calcium, two peaks are showing at the binding energy of the 348 and something like the 350 energy, so that calcium present in the 2 plus, calcium is 2 plus, copper is 2 plus state, and titanium also is present as a 4 plus state. Here the dielectric properties of that material. In the case of dielectric properties of that material, we have seen that the at a lower temperature, 300 to 400 degrees centigrade, all frequency, at all frequency, the dielectric constant is not much variable, but in the case of the low frequency range like 1 kilohertz, the dielectric constant variable with the temperature. So here we can say there is a large number of phenomena, Maxwell relaxation and other phenomena. We can see that the dielectric constant vary with the temperature. But in the case of the higher frequency, the dielectric constant is independent on the temperature at 100 kilohertz. And we have also seen that the dielectric loss also will be increased with the increase in temperature. And it is the graph between the dielectric constant, dielectric loss, and the between the frequency. In the case of the frequency, whenever we see increase the temperature, the dielectric constant increase with the increase in temperature, as well as the there is some relaxation formula also solved by the dielectric loss. And these are the we have studied with the some selected few selected temperature on this, and it means the dielectric constant and dielectric loss is depend upon the frequency as well as of that one, as 1 kilohertz, 10 kilohertz, and 10 kilohertz at the temperature range. And here also with the dependent upon the frequency range. In the lower frequency range, there is a low frequency range. There, whenever the temperature, whatever the temperature, there is a independent on the frequency range of the conductivity. Here is the conclusion. Whenever we synthesize this material by the solid state and other method, but in the case of the our non-aqueous synthesis method, it is a greater than, much better than the other chemical routes and the solid state, because this metal provide the energy saving and as well as the time duration, and it can also play single step method. And also we have seen that the biometal nature of the grain size found in that material, and we have seen that the dielectric constant also the frequency and temperature independent. The major future scope of that material, and whatever we use in the future in capacitor material, we have to if we normalize or stabilize this dielectric material to a low frequency range and low dielectric loss, we have to use this one in the missile system, drone system, and other energy storage system in the device. There are lots of property we have to need to discuss with that material, and in the future we have to plan to discuss with the material with the processing parameter and with the processing atmosphere also. So these are the some product development we have used in this device for the lithium ion battery, and as well as the we have to use the capacitor material, hydrogen fuel cell, and we have got a lots of number patent on these devices. So these are the some few publication of these materials. So thank you. And this is my university, as well as I am working for as a visiting research professor in the University of Ulsan. So thank you for your kind attention. If you have any question, please ask me.
Hello, sir. Am I audible?
Yes,
Okay.
you are
Sir,
audible.
in one of the slides, you showed that cation exchange increase the capacitance of CCTO. Is there any
Yes.
is there any particular trend, like which cation increases the capacitance, or which type of cations decrease the capacitance?
Actually, there is a lots of fight in the case of CCTU, titanium, calcium, copper. Whenever we discuss about the titanium, See, most of the iron like vanadium iron and the titanium replaced by the PV. So this can be good. But in the case of the train, it will be good because we have here not only the dielectric constant. The major problem for that material is the dielectric constant is good, but the major problem for that material is the high dielectric loss. So we have to need to compromise both of them.
Okay. Thank you, sir. Thank you so much for your lecture. And now I will invite Dr. Rupesh for the formal vote of thanks.
Hello. Hello, sir.
Hello.
Am I audible?
Yes, yes.
Okay. Okay. Good evening. Good afternoon, everyone. Hello. Hello. Hello.
Hello. Yes, yes.
Okay. Good afternoon, everyone. So, on behalf of the organizing committee, I would like to extend our heartfelt gratitude to our distinguished speaker, Professor Lakshman Singh sir, for your profound presentation on the topic efficient synthesis of AbO3 type perovskite using a robust and economical method. Your insight into the synthesis of these multifunctional materials were exceptional, and we particularly appreciated your crucial compounds like as barium titanate and strontium titanate. So your expertise has given us a clear roadmap for the scalable production of high performance perovskites. We are truly grateful for this your time and knowledge you have shared with us today. Thank you once again, Professor sir.
Thank you so much.
Thank you, sir. So now you
Okay.
can, yeah, now you can disconnect, sir.
Okay, thank you so much.
Thank you.
Now we have a talk of Miss Dipti from Patna University, Patna. Honorable Chairperson, respected faculty members, and all fellow researchers, a very warm welcome to all of you. Myself, Dipti, I am a research scholar from Patna University under the supervision of Professor Dr. Rajneesh Kumar sir. I am very thankful to PG Department of Chemistry, Magad University, for organizing this national conference on evolving chemistry for a transforming world, sponsored by Anusandhan National Research Foundation. So the title of my paper is Synthesis, Spectral Characterization and Antifungal Activity of Copper Dibiguanide Complex against a pathogenic fungi potential as a bioactive agent. These are the key points of my research work, which includes abstract, introduction, methodology, analysis, result discussion, conclusion, and future scope. This is the abstract part. The introduction part includes biguanides, which is composed of two guanine molecules, which forms a highly conjugated system. This is the structure of biguanide molecule, which have two donor nitrogen sites. One is the imino-nitrogen site and the other is the amino-nitrogen site. And these two nitrogen donor sites are very helpful in forming stable metal complexes. Biguanides have a wide range of therapeutic properties like metformin is such biguanide which is used as a anti-diabetic drug. Chlorhexidine is also a biguanide which is used as an antiseptic. The methodology, this is the methodology which includes synthesizing the biguanide sulfate ligand. The second is the metal complex synthesis, and then thereby characterizing the ligand and the metal complex. The main focus is to find out the antifungal activity of the synthesized metal complex using the disc diffusion method. So this is the synthesis process of biguanide sulfate that I have synthesized in the lab. This is the real photograph of the biguanide sulfate, and this was synthesized using the Frederick and Smolka method. This is the elemental analysis of biguanide sulfate, in which carbon content and the nitrogen content is found as 10.11 and 29.90 respectively. This is the IR spectral analysis, in which the peak around 3400 centimeter inverse shows the NH stretching, while the peak around 1500 shows the C double bond N stretching, which corresponds to the guanidine molecule. The stretching around 1100 shows the sulfate stretching. This is the UV spectral data, which shows the pi to pi star transition. The one which is intense peak and the weaker peak is around N to pi star transition. So this was for the biguanide sulfate ligand. This is the interpretation of UV spectrum, IR spectrum. Then the synthesis of the metal complex, that is copper ethylene dibiguanide sulfate. This is the elemental analysis, the IR spectral data, which shows the peak around 3400 shows the NH stretch, while the peak around 1500 shows the CN stretch. The peak around 1100 shows the sulfate stretch, and the peak around below 500 shows the copper nitrogen stretch, which corresponds to the metal complex. This is the UV spectral data. The broad peak around below 300 shows the charge transfer spectra, while the peak around 500 to 600 shows the DD transition. This is the interpretation of IR spectrum, UV spectrum. Now the microbial activity of the biguanide and metal biguanide complex. So the synthesized complex is tested for A. niger, Aspergillus Microsporus canis, and Candida albicans. Under 3 different concentrations, I have studied the zone of inhibition. This is the experimental method that I have used. That is a disc diffusion method. These are the tabular form for the different fungus that I have studied, in which Aspergillus niger shows no activity, and Aspergillus fumigator shows moderate activity, around 9 millimeters at high mg per ml. M. canis also shows no activity for my synthesized compound, while the Candida albicans shows a good dose-dependent activity, and that is a zone of inhibition. This is a photograph of different the 3 concentrations that I took for the 4 fungus. So I can conclude that this is the structure for the synthesized complex, the real photograph of the metal biguanide complex. In the future, I am planning for broadening the biological test for this synthesized compound. Thank you. I have a question. Yes, ma'am. The concentration which you used for antifungal activity. Yes, ma'am. It was same for all the fungus. Most effective was 100 mg per ml concentration. At that highest concentration, zone of inhibition was 10. Yes, ma'am. So it shows a maximum inhibition at which my synthesized compound shows the maximum zone of inhibition. Okay, thank you.
किसी और को प्रेजेंटेशन देना है? हाँ सर.
A very warm good afternoon to all my distinguished professors and chairpersons and my fellow colleagues, and always along with my peers. They have been given the kind attention for the 2 days national conference has been organized in our organizing body, sponsored by the National Research Foundation, New Delhi. So, starting before that, I am going to start my topic. What I have been selected. Bridging the advanced research for carbon and hydrogen footprint with sustainable and green energy to overcome LPG scarcity. This is my abstract. Now just I am going to focus last line, which is very important for this abstract. This approach moves beyond conventional energy inventories by integrating AI-assisted process optimization, waste to energy pathways, and hybrid fuel systems, offering a transformative alternative to LPG dependency. The proposed framework not only contributes to reducing greenhouse gas emissions, but also strengthens India's energy independence. As far we know that aligning with the goals of Vision India 2000 at the rate of 2047, जो हमारा विकसित भारत 2050 तक बनाने के जो उम्मीद है, उस पर हम बहुत खरा उतरेंगे यदि हम लोगों को ऐसा कोई सपोर्ट मिले, ऐसा कोई ऐसा लैब इंस्ट्रक्शन मिले, और खास करके ग्रीन एनर्जी में हम लोग ज्यादा से ज्यादा इन्वेंट कर सकते हैं. इंट्रोडक्शन. आज जो हम लोग फेस कर रहे हैं, बहुत सारे प्रॉब्लम्स फेस कर रहे हैं, उसके बारे में भी हम थोड़ा डिस्कस करेंगे. लेकिन जो मेजर पार्ट है हमारा प्रॉब्लम का वो है कि रैपिड इंक्रीज इन एलपीजी डिमांड इन इंडिया, क्योंकि सब लोग जान रहे हैं कि जो हमारा मिडिल ईस्ट वॉरशिप स्टार्ट है यूएस ईरान के बीच में, जो इन्फ्लेशन राइजिंग हो रहा है, हम लोगों की नीड्स बढ़ रही है और हम लोग उसके बारे में कुछ सोच नहीं पा रहे हैं, और हमारी जो डिमांड ऑफ एलपीजी वो तो बढ़ रहा है लेकिन हमें वो अवेलेबल हो नहीं पा रहा है. तो इसके लिए मैंने कुछ ऐड किया है अपने इस पेपर में. LPG scarcity in rural and developed, high carbon footprint of conventional fuels, limited adoption and lack of integrated carbon management. ये जो आप देख रहे हैं स्कल्पचर जो मैंने डाल रखा है, ये बेसिकली हमारा ये ईरान कॉन्फ्लिक्ट चल रहा है अभी 2026 में, उसके ऊपर हमने फोकस किया है. और our economies still run on oil, was like America and Iran express how fragile this dependence is. When supplies is disrupted, prices rise, people suffer, and instability grows. एनर्जी इंडिपेंडेंस मीन्स रिन्यूएबल एनर्जी. हम लोग को पता है कि एनर्जी इंडिपेंडेंट हम लोग को बनना है, क्योंकि आज के डेट में एनर्जी इनसिक्योर है हमारे लिए, बट सिक्योर करने के लिए मुझे रिन्यूएबल एनर्जी को फोकस करना होगा. तो इसके लिए मैंने थोड़ा सा आगे बढ़ा है जी. यस सर. These are my conceptual framework. मेरा जो मोटो था, alignment with vision in India 2000। देखिए, मैंने जो अपने टॉपिक्स में दे रखा था उससे आपका काइंड इंटेंशन हम बनाना चाहेंगे। जो मैंने यहाँ पे दिया है, शायद अनुसंधान नेशनल रिसर्च फाउंडेशन को यदि ये अच्छा लगा तो शायद हमारे यहाँ लैब प्रोवाइड हो तो हम लोग के मदद से या फिर हम लोग अपने जितने भी जीआरएफ स्टार्टअप हम लोग डाल सकते हैं और हम लोग कर सकते हैं इसके बारे में। मैंने जो आइडिया जो मेरे दिमाग में आया, मैंने एक ले लिया, वाटर हैसिंथ एंड एग्रीकल्चर रेसिड्यूज प्रेस्ड बायोगैस। So, motto is that advanced biomass to fuel strategies for sustainable LPG alternatives. It is scientifically structured, focusing on the best LPG alternatives using water hyacinth agriculture residues like rice husk and wheat straw. करके हम इसमें इन्वेस्टमेंट हमारे यहाँ देहात में धान का भूसा, चावल का भूसा, गेहूं का भूसा वगैरह बोलते हैं, उससे एलपीजी प्राप्त कर सकते हैं, इजिली कर सकते हैं। मैं आपको बताऊंगा एक टन हमारा राइस ग्रेन यदि हम लें तो हम 138 किलो एलपीजी इक्विवेलेंट के बराबर हम सीबीजी गैस प्राप्त कर सकते हैं। वाटर हैसिंथ मैंने इसलिए लिया है क्योंकि बंगाल का आतंक को जाना जाता है, जो कि 1834 ईस्वी में इसके बारे में बोला गया था। ओके सर, बैकग्राउंड एंड प्रॉब्लम स्टेटमेंट। कौन कौन से प्रोसेस हमें यूज करने हैं इसके लिए को प्राप्त करने के लिए मैंने दे रखा है। वाटर हैसिंथ एग्रीकल्चर रेसिड्यूज दोनों को मैंने कंपैरिजन भी किया है, एनर्जी एफिशिएंसी कंपैरिजन के साथ आप देख सकते हैं। इन्वायरमेंटल इम्पैक्ट, जो कार्बन न्यूट्रल साइकिल, रिड्यूसेस वाटर पॉल्यूशन, हैसिंथ रिन्यूएबल, यूटिलाइजिंग एग्रीकल्चर वेस्ट, रिड्यूसेस स्टबल बर्निंग, सपोर्ट्स क्लाइमेट गोल्स एंड सस्टेनेबल। लैब स्केल एक्सपेरिमेंटल सेटअप मैंने डाल रखा है, हमें जो है वो ये दिख रहा है, एफिशिएंट प्री ट्रीटमेंट टेक्नोलॉजीज, कैटलिस्ट डेवलपमेंट फॉर एलपीजी सिंथेसिस, हाइब्रिड सिस्टम इंटीग्रेशन, स्केल अप चैलेंजेस। मैंने पहले अर्लियर बता रखा था कि हाई पोटेंशियल हमारे जीआरएफ पीएचडी पैटर्न्स एंड स्टार्टअप मॉडल की। कंक्लूजन आ गया, लास्ट हो गया सर। तो फाइनली कंपैरिजन मैंने किया, जो कि वैल्यूएबल इनसाइट जो अपने इस पेपर में दे रखा है मैंने। तो मोस्ट इंपोर्टेंट रिसर्च कंक्लूजन इज बेस्ट प्रैक्टिकल सिस्टम वाटर हैसिंथ, जो रियल बायोगैस देती है, और जो एग्रीकल्चर रेसिड्यूज मैंने इस्तेमाल किया है वो एडवांस्ड एलपीजी सिंथेसाइज के लिए यूजफुल है। तो रिसर्च एनेबल्स सस्टेनेबल अल्टरनेटिव टू एलपीजी एसेंशियल, हाइड्रोजन प्लस कार्बन कैप्चर यूटिलाइजेशन एंड स्टोरेज, फ्यूचर एनर्जी पाथवे हो सकता है, क्लीनर एनवायरनमेंट एंड एनर्जी सिक्योरिटी, चूंकि हम लोग मैंने बताया कि रिन्यूएबल एनर्जी इज मोर एनर्जी सिक्योर्ड, रूरल एम्पावरमेंट, और हमारे बिहार में खास करके जो पलायन कर रहे हैं वो रुक जाएंगे और यहाँ पर काफी रोजगार सकता है। तो थैंक यू। फर्स्ट आई वुड लाइक टू एक्नॉलेजमेंट।
नहीं, पेन ड्राइव नहीं है, पेन ड्राइव नहीं है, निकाल लो। नहीं, सेव नहीं है, नहीं नहीं नहीं। स्लाइड पे चला यहीं आ हाँ जी आके नीचे ही आ।
थैंक यू एवरीवन। आपके सपोर्ट और डिलीजेंस के बिना ये पॉसिबल नहीं हो पाना था। नाउ I would like to request all our members, including Dr. Ravi, to come forward to facilitate judges of the poster competition. Dr. Sunil Kumar from JJ College. Sir, please come to receive the memento as a token of gratitude from our side. Dr. Devapratim Das from PG Department of Chemistry, Gaya College, Gaya. Dr. Akil Ahmed from Mirza Ghalib College. Thank you, sir. Now I request all the three judges of the poster evaluation to please come forward to give the certificates to the winners. Please announce the result.
थैंक यू सो मच मैम। पोस्टर प्रेजेंटेशन का जो सेशन रहा है बहुत ही अच्छा था, बहुत इंटरेक्टिव था। सारे बच्चों ने बहुत अच्छे पोस्टर्स बनाए थे। चूंकि तीनों लोगों की मजबूरी ये थी कि हमको उसमें से 2 सेलेक्ट करना था, तो जिन लोगों ने पार्टिसिपेट किया उनके लिए हमें हमारी ऑर्गेनाइजिंग टीम की तरफ से तहे दिल से बधाई और आगे फ्यूचर में और अच्छा करें इसकी शुभकामनाएं। Second best poster result goes to Mr. Rajiv Ranjan, research scholar है ये, PG Department of Chemistry, SS College, और इनका टॉपिक था रिव्यू ऑफ टॉक्सिक हैवी मेटल कैटायन इन ड्रिंकिंग वाटर। इनके लिए एक जोरदार तालियां हो जाए। और जो फर्स्ट पोजीशन पोस्टर प्रेजेंटेशन में पाई है एक बच्ची है, बहुत ही अच्छा प्रेजेंटेशन दिया उसने, मिस कल्याणी चौधरी। ये रिसर्च स्कॉलर है जूलॉजी डिपार्टमेंट की, मगध यूनिवर्सिटी बोधिया। इनका प्रेजेंटेशन बहुत ही लाजवाब रहा था, तो इनको फर्स्ट प्राइज मिलता है।
थैंक यू।
अब हम सर्टिफिकेट्स डिस्ट्रीब्यूशन स्टार्ट करते हैं। हम नाम अनाउंस करेंगे, जो प्रेजेंट है प्लीज आके अपना सर्टिफिकेट कलेक्ट कर लीजिए। मैं नाम मिस्टर कौशल कुमार, MSY कॉलेज गया जी आ रहा है। रवि सर. थ्री वो हो गया ना. बैठा हुआ ज्यादा कंफर्टेबल है, सिग्नेचर भी कराना है. अच्छा चलिए.
रंजीत कुमार.
अंजलि कुमारी. अंजलि कुमारी, पीजी डिपार्टमेंट ऑफ केमिस्ट्री. मिस्टर अशोक कुमार, पीजी डिपार्टमेंट ऑफ केमिस्ट्री. मिस्टर धीरज कुमार, पीजी डिपार्टमेंट ऑफ केमिस्ट्री. मिस्टर गौतम कुमार यादव. मिस्टर मनदीप कुमार, पीजी स्टूडेंट. मनदीप. मिस पूजा कुमारी, पीजी स्टूडेंट. पूजा नहीं. मिस्टर रवि कुमार रंजन. रवि कुमार रंजन तो उधर रवि भी आ रहा. मिस्टर रुपेश कुमार. रुपेश
रुपेश
है. ये साइन कौन. मिस्टर संजीव कुमार सोनू आ गया है. मिस्टर सुजीत कुमार. सुजीत कुमार. सुजीत इज नॉट है. मिस्टर अविनाश कुमार किंकर. अविनाश कुमार किंकर. सोनू. सोनू है इसका नाम. नहीं, सोनू है इसका नाम. अरे बस ये नहीं है, ये नहीं है, ये नहीं है,
नाम पे.
ये नहीं है, नहीं, ये नहीं है नाम. ये है अविनाश कुमार किंकर. अजरा यास्मीन. नागेंद्र कुमार. नागेंद्र भी आएगा. रोजी परवीन. हाँ रोजी भी है. शबनम कुमारी. शबनम. शुभम. विश्वजीत कुमार. मिस्टर विश्वजीत कुमार नहीं है. मिस्टर अभिषेक राज. सर आप रख दीजिए ना, मैं उठाती रहती हूँ. मिस्टर अभिषेक राज. मिसेस अनीता कुमारी. मिस्टर चंद्र प्रकाश चौधरी. चंद्र प्रकाश चौधरी. मिस्टर दीपू कुमार. दीपू इज दैट. मिस कुमारी पूजा भारती. कुमारी पूजा भारती.
अविनाश. जिन लोग को मिल गया अपनी जगह पे बैठे. अविनाश. अविनाश कुमार किंकर. सिग्नेचर जरूर कहें. अविनाश बैठो अपनी जगह पे. अविनाश बैठो अपनी जगह पे. जिनका हो गया वो बीच में खड़े न रहे. जिनको मिल गया वो अपने जगह पे जाके बैठे.
मारवाड़ी संदीप कुमार. मिस्टर प्रमोद कुमार. प्रमोद इज देयर. मिसेस प्रांजलि राज. मिस्टर राज भारती. मिस्टर रवि प्रकाश जायसवाल. मिस्टर संजय कुमार. मिसेस शबनम रानी. शबनम रानी. मिस्टर सिद्धांत यादव. मिस्टर सोमवीर सिंह. मिस्टर सुरेंद्र कुमार. मिस्टर विकास सिंह. श्वेता भट्ट. श्वेता भट्ट. मिस्टर अजय कुमार. अजय कुमार. मिस अनामिका कुमारी, मिस अनुश्रेया, डॉक्टर अश्विनी कुमार, अश्विनी, मिस्टर चंदन कुमार, चंदन है, मिस्टर चंद्रेश कुमार गुप्ता नहीं, मिस्टर गौतम कुमार, मिसेस ज्योति कुमारी सिन्हा, ज्योति मैम है, मिस्टर कमलेश चौधरी, मिस्टर मनीष कुमार, मिस्टर मिथिलेश कुमार शर्मा, मिस्टर मुकेश कुमार, मिसेस नेहा कुमारी, मिसेस पल्लवी कुमारी पुष्पम, ये नहीं होगा, मिस्टर पंकज कुमार टाइगर, ऐसे लगा, जिनको सर्टिफिकेट मिल गया है प्लीज बी सीटेड, बैठ जाइए। नहीं, मुकेश था,
मनीष बुलाया जाएगा।
आप भी रुक जाइए। मिस्टर पवन कुमार, पल्लवी कुमारी पुष्पम, ये लीजिए। मिसेस प्रतिभा सिंह, मिसेस पूजा कुमारी, मिस्टर राजीव रंजन रमन, मिस्टर रविकांत कुमार रविकांत, मिस रेणु कुमारी, रेणु कुमारी, राजीव दिया तो है, दिया है राजीव रंजन का, मैंने दिया है, ये उठ के आए हैं, मैंने दिया है, किसी और को तो नहीं दे दिया। मैडम को देखिए,
नाम देखते रहेंगे, सही है ना?
ये सर मेरा
मैंने कहा ही है।
आपका क्या है? पूजा कुमारी बोला गया है?
हाँ, पूजा कुमारी भी बोला गया। ये भी कोई बात नहीं, फोटो में कुछ नहीं।
रेणु कुमारी नहीं, ये क्या टॉपिक है?
संजीव कांत वर्मा गया,
साइन कर देना सभी।
मेरी अटेंडेंस होगा।
सरिता शर्मा,
देख लीजिए तो
मिस्टर सत्यार्थी सौरभ, ठीक है, मिस सविता कुमारी,
है।
मिस्टर श्रवण कुमार, सुधांशु कुमार सिन्हा, श्रवण दिख ही नहीं रहा है, कोई उठ के आ रहा है, सुधांशु नहीं है, मिस्टर सुमन कुमार, मिस्टर सुनील कुमार, मिसेस तनीषा नहीं, उदय शंकर प्रसाद, उदय है, बनीता, डॉक्टर सुदामा चौधरी, सुदामा सर, मिस्टर अनिल कुमार, अनिल सर भी हैं, तनीषा
अनिल कुमार कौन?
बस उदय, बस जाओ। डॉक्टर इरफाना नाहिद, डॉक्टर इरफाना नाहिद, डॉक्टर कुमारी अनीता सिन्हा, डॉक्टर कुमारी अनीता सिन्हा, डॉक्टर मोहम्मद सहाबुद्दीन, हाँ डॉक्टर मुकेश कुमार, अभी थे ना, डॉक्टर मुकेश कुमार, डॉक्टर रामचंद्र कुमार, डॉक्टर संजय कुमार यादव, संजय कुमार यादव सर, डॉक्टर सतीश कुमार, डॉक्टर शिवचंद्र कुमार, शिवचंद्र सर, शिवचंद्र कुमार, शिवचंद्र, नहीं वो नहीं। डॉक्टर प्रकाश सहाय नहीं है, डॉक्टर अखिलेश सिंह, अखिलेश सिंह, डॉक्टर आरती कुमारी, डॉक्टर निर्मा मौर्य, निर्मा मौर्य, डॉक्टर प्रीति रानी, डॉक्टर रोहित श्रीवास्तव, डॉक्टर अकील अहमद, डॉक्टर देवव्रतिन दास, शैलज, जिनको भी सर्टिफिकेट मिल गया है वो साइन जरूर कीजिएगा, अटेंडेंस है ये। ये तो 2 ही है। ओके, मिस्टर रंजीत कुमार, रंजीत है, ठीक है। मिसेस आकांक्षा प्रिया, मिस्टर आशीष कुमार, आशीष कुमार, मिस्टर अविनाश चंद श्रीवास्तव नहीं आया होगा, मिस्टर गौतम कुमार, गौतम पीजी डिपार्टमेंट ऑफ केमिस्ट्री, पीजी स्टूडेंट, गोल्डन कुमार, मिस्टर गोल्डन कुमार सर, गोल्डन, मिस्टर नीतीश कुमार, मिसेस राखी कुमारी, राखी कुमारी पीजी स्टूडेंट, गोल्डन आ रहा है, मिसेस रिंकी कुमारी, रिंकी पीजी स्टूडेंट, मिस्टर सम्राट पुष्कर आनंद पीजी स्टूडेंट, मिसेस स्नेहा कुमारी पीजी स्टूडेंट, मिस सुमन भारद्वाज पीजी स्टूडेंट, पीजी डिपार्टमेंट ऑफ केमिस्ट्री, सुमन है, मिस्टर अमन कुमार मिश्रा, अमन कुमार मिश्रा, मिस्टर निहित परमार, मिस्टर मिस्टर रवि रंजन कुमार,
हेलो,
मिस्टर शैलेश कुमार, मिस स्वप्निल कुमारी, मिस्टर अभिरंजन कुमार, अभिरंजन, मिस्टर आदित्य राज, Mrs. Bharti Rani, Mr. Deepak Kumar, कोई बात नहीं, मिस्टर दीपक कुमार, मिसेस कोमल राय, कोमल नहीं आई है, मिस कुमारी प्रियंका रिसर्च स्कॉलर मगध यूनिवर्सिटी, मिस नीतू कुमारी रिसर्च स्कॉलर डिपार्टमेंट ऑफ केमिस्ट्री, मिस्टर प्रमोद कुमार शाह, मिसेस प्रियंका यादव रिसर्च स्कॉलर गया कॉलेज गया जी, मिस्टर रंजन कुमार, मिस रीना कुमारी, मिस्टर शंभू कुमार सुमन, मिस्टर संतोष कुमार, मिस स्मृति सिंह, मिस सौम्या, मिसेस सुष्मिता चौधरी,
आप आगे बोलिए हम निकालते हैं।
हाँ, मिसेस सुष्मिता चौधरी, मिस्टर विकास कुमार, हाँ हो गया, मिस बंसीधर, ये तो आएगा नहीं, मिस्टर अमित कुमार सुमन, दे दीजिए अमित कुमार सुमन, अनोज कुमार, मिस अपराजिता कुमारी, मिस्टर अविनाश कुमार, ये रह गए हैं मैम।
उलट के रखना पड़ेगा इसमें।
Mrs. Dipti, research scholar of Department of Chemistry, Patna University. Dr. Jay Prakash, research scholar, PG Department of Chemistry. Mrs. Jyoti Rani, research scholar, PG Department of Chemistry.
मनीष कुमार, मुकेश कुमार, नागेंद्र पंडित,
मनीष है लोग, मुकेश कुमार गुप्ता, नीतीश कुमार हो गया,
पंकज कुमार, प्रमोद पासवान,
पंकज है,
बोलना है तुरंत, प्राची सुमन, ये क्या है, प्रतिनव चतुर्वेदी, राजेश कुमार, रामदेव महतो, रेखा कुमारी, शब्बीर हुसैन, संतोष कुमार,
भीड़ बढ़ जाएगी, रुक जाएगी,
फास्ट नहीं कर देखिए कितना फास्ट, तुरंत भीड़ लगा
नागेंद्र पंडित नहीं, प्रमोद, रामदेव महतो कौन है? रेखा कुमारी,
हम लोग अलग से ऑर्गेनाइजिंग टीम का बनाएंगे तो
बुलाएंगे।
दैट सर्टिफिकेट, वो सर्टिफिकेट भी देंगे, ठीक है ना। चलिए स्टार्ट करें।
संतोष कुमार, हाँ करो,
हाँ, सत्येंद्र कुमार, दो सत्येंद्र कुमार है, पढ़वा लीजिएगा कौन सा सत्येंद्र कुमार है दोनों से।
शनि है,
सनी कुमार, श्रीकांत पासवान, सुजीत कुमार, सुमित कुमार पंडित, स्वामी विवेकानंद, स्वामी विवेकानंद, तनुश्री नहीं है, अनुराधा है, अनुराधा, शिल्पी सिंह, विजय कुमार, अवधेश प्रसाद, कुमार सौरभ, मस्कूर आलम, मोना कुमारी, राघवेंद्र कुमार, इधर से नहीं लीजिए, बाद में लीजिएगा, बाद में सहदेव कुमार, सरोज कुमारी, सरवर इकबाल, सुधांशु रजक, अभिजीत कुमार श्रीवास्तव, अनूप कुमार, भगवत गिरी गोस्वामी, प्रतिभा महतो, राजेश कुमार, आइए आइए, ये कौन सा राजेश? अच्छा, नीतीश जायसवाल, अरविंद कुमार सिंह, धर्मेंद्र कुमार, रवि कुमार सिंह, इनको घुसाइए, 92 पे लगाइए, 92 पे लगाइए।
प्रमोद पासवान देखे कहीं है? अच्छा पहले सीरियल लगा के हो गया ना?
हो गया, सीरियल हो गया।
ये बच्चा रह गया अभी।
हाँ, चलिए अब किसको किसको नहीं मिला
ला के दे देना।
दोनों डाल लेते हैं।
All of you are requested to please settle down. हम लोगों को अभी कंक्लूड करना है सेशन, तो हम लोग नेशनल एंथम से इसको कंक्लूड करेंगे। जन गण मन,
अपनी जगह पे खड़े हो जाइए नेशनल एंथम के लिए।
जन गण मन अधिनायकी जय हे भारत भाग्य विधाता। पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा। विंध हिमाचल यमुना गंगा ऊचल जलधि तरंगा। तब सुबह नामे जागे, तब सुबह आशीष मांगे। गाए तब जय गाथा, जन गण मंगलदायक जय हे भारत भाग्य विधाता। जय हे जय हे जय 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 हे भारत माता की वंदे।
हेलो, जिनको सर्टिफिकेट मिल गया है वो अब जा सकते हैं। अगर साइन ना किए हो तो रुकिए, और बाहर हम टी का इंतजाम है, चाय पी के ही निकलिएगा। थैंक यू।
थैंक यू सो मच।